Hello guys, let's start with a question. What do you expect to see, learn after reading such a title, heading? Well, but I will tell you right now, right away. You will learn more than you expected, and you will see something that you have never seen anywhere else. If you are patient, and watch carefully, okay? Yeah, and can withstand this English. So the material was prepared by 3 engineers. Wow. So here I have ammeters, there somewhere there. Oops, sorry. Here I have voltmeters. I have different equipment in this board. I have a fridge. And guys, sometimes will be a lot of water in my video, yeah? Do you say this way in English about useless information like water? I have a lot of water here. It's my video. I do what I wish, especially because it's quite boring when autopilot driving me, but you will still get a lot of useful information. Yeah, and my water is mixed with a lot of useful information and with stronger than 60 by 40 in favor of useful information. Yeah, I wanted to call this like a generator for dummies, but guys, I think I will cover also some serious subjects, and probably sometimes we'll need your advice from some experts. Now let me read out what questions are asked most often on this topic. They will actually be answered in this video. So, how does a car, car doesn't matter. How does a battery know how much current to draw from an alternator? First question. Second, how do I go about verifying my alternator output? Number 3, should I be concerned that running my vehicle with the light bar on constantly is going to prevent the battery from charging? Quite an interesting question. Good question, but it's a simple question. 4, how much current does an alternator supply in this situation? Specific, this, or another one. How much power do I need for? Okay. And number 6, will I damage battery by constantly charging this from the alternator? So, 6 questions. They will be mixed with water, but you will get answers. Probably we will need to split on 2 parts. It seems that one part is going to be too much water. I need to change a course. I answered the first question. How does the battery, know how much it needs from the generator, or well, alternator? Sometimes I will use generator. Yeah, so how much the battery know, how it knows how much to take power, current from the generator? It doesn't, guys, it doesn't. A battery for a generator is simply a load that has its own resistance, impedance, yeah, I think the right pronunciation, but it is variable. It depends on the state of charge. This is about the chemistry of the battery, lead battery. Charged battery has a high impedance, so high resistance, and large current cannot flow in its circuit. This is about Ohm's law. We will see this with examples and perhaps talk more about this subject, although there is not much to talk about it here. So I remind you, have ammeters and voltmeters. So we will see these things on examples. If you don't know anything about the Ohm law, then look at a simple one video from someone, yeah? But guys, just keep in mind, remember a simple statement. A battery is just a variable load current from the generator, alternator, flows into it like everything else and as much as is needed for its current resistance state of charge. I have some fish there. The fish like on my t-shirt, it's for luck. No. Guys, if someone knows where I got this t-shirt, probably you travel there, let me know in comments. And some ship is going there. Wow, that's not good. Yep, the first water began. I don't show you the whole 300 feet reeling process. Here I have new technology for how you call this, for netting the fish. Now we'll see what is there and probably will be quite surprised. So it's a small trout, yeah, that I need to release. So we addressed the most, wait, it almost crossed my planners, so I had to take care about this. Fortunately material's not blown out because I kept them here. So let's try again. We answered the most important question, and let's go on the second one. How do I go about verifying my alternator output? So now we are talking about this particular alternator or generator. Everything is clearly described in the documentation. Look, alternator system test, several steps. I'm not going deep to them right now, but number 8 is the most interesting for us. RPM and the current dependence. Screen this chart if you don't have it, and keep the screen on the side because we will look deeper into this one. I will now include the material collected at the very beginning of testing, everything that I have done here. Yeah. So, by the way, regarding how and what I have done here, I have a kind of Santa Barbara 13 episodes in the playlist on electric in the board. I'm looking that I'm on the right way. So therefore I'm not going to explain this stuff now. So material that I shot was a part of test without voice, and then I did voiceover. So the material will actually answer the question on how to check the operation of the alternator. I also recorded some introductory moments and questions to discuss with you, so let's watch. First of all, we will look at the alternator system, how it works according to the datasheet for this engine from 40 to 60 EFI. The most interesting chapter is this one, where we see this diagram, RPM and amperes, and some interesting notes. I was speaking with two engineers. We discussed several things about alternators, batteries, and we come to certain conclusions. I will tell you them. If somebody quite smart looking this video, you can give your comments on that. Here's quite interesting note about the voltage regulator reduces the charging current as the battery voltage increases. Maximum current, blah blah blah. So it looks like a smart charger that can analyze battery voltage. For sure it can. But what we not agree, all three of us, that does it actually hold this 14.2 voltage? You probably already have seen this or will see this. I don't know how I will edit this video yet. Does it just hold for 14.2 and then follow the current that it provides, or it can also set the different voltage. If you are quite smart in these things, please do your comments. 14.2 we see, that is the maximum that is set by Alternator, and you can see 1000 RPM. The battery is not discharged, it's quite fresh, but fresh enough. So now we reduce RPM to the minimum that is possible here on this engine, which is about 700. We don't see much voltage drop. Yeah. Almost nothing. So 14, the same 14.2 basically. Yeah. So we don't have any current. 0.2 is nothing. And 2 amperes the alternator gives, probably because the battery still requires some charging. Not probably, but it is. There's constant voltage, small current charging. Increase RPM doesn't change the situation. Here I ask my wife to start engine while I'm doing video. You can see even -40, something like that. We will see a better picture later without sun, but here is the interesting point that you can see constant -23. I was surprised, what is going on? And then I found that my dear wife a little bit afraid to release the key, otherwise the engine will stop what she is thinking. So, and we can see nice work of the state, and we also drain the battery. We will need this for future. Here was some slow, then I realized. And after we little bit discharge the battery, we can see more current given by alternator to the battery, while we still have low, and we see also voltage drop, while we still have low current from consumers. I decided to make it myself. Yeah, so start engine, you can see 55, quite nice current from the first battery, as you can see. Yeah. And we don't have any loss, as you can see, 0.3, almost nothing. So the generator still provides 7 amperes because the battery, discharged battery, I discharged the batteries because I wanted this test. So, and the battery with low resistance, because of discharge, it wants more current. Here we see, you can see 1366 voltage. Is it the voltage drop? Is it the alternator that set 14.2 but cannot keep it? That's quite an interesting question. We didn't agree on it. So yeah, 13.6. Yeah. So I remind you that I do voiceover on the material that I recorded a month ago. I don't remember exactly what was there. So I reduce RPM now. It was recorded in evening time. I was alone there. You can see nice pictures in the sunshine, and we can read clearly. So 3.3. You can see the chart. Yes, with low RPM, the minimum we can see 3 on this chart or diagram. And increasing RPM, we see more current. Everything according to data sheet. You will either see this. I hope I will put this on left or right side of the video. I think on the left, or if not, then at least we have seen already this in this video, so we can just compare the results. You see that. So 1000, it should be 12. So guys, look, the voltage is almost 14.2, but the current is 5.5. Why not 12? Why not 10? I can't believe that the battery is charging so quick. That I don't know. So again, reduce RPMs. This is current. Yeah, I remember that I will do throttle and more gas. And we should actually see quite a lot more than 12 if the battery requires this. But we don't see 5, we see 6. We are definitely over 1000, but we see only that current. Is it because the battery already quite charged? Probably, yes. I wanted to show you RPM, but water supply was failed on this engine, so I will now stop the test and yeah. Oops. That is the second battery now connected, and I'm trying to start from this battery. Yep. 0.9 consumption is from the radio on the pulse. So you can see the second battery on the position 1 means so 13.7, the second battery. So position 1 means that it is connected to the alternator. Decided to repeat experiment here. So do we see something more interesting? So for amperes, the battery is different, definitely doesn't need more, but 13.5. So I'm increasing. Okay, so I'm about to add more gas. So we definitely over 1000. We should see 12, but we don't see 12. We still see 5. Why? Because no loads that require this. The battery is quite charged. It doesn't need that amount. The consumers are only 0.3 amperes. So the generator will not give more power than someone requires from this. Yeah. So everything by theory. Okay, we just confirm how it works. Everything according to the law. 14. Let's move on some examples actually. So during the second fishing trip, after all these things have been done, I tested various operating modes when we consume more than the generator can provide. For example, the dependence on the current and speed, so RPMs, and there was a lot of interesting things. At the end, we will also look how much exactly how much amperes hours we consumed. When I recorded this material, I didn't have any script, as I never have, so take it as a separate video. And there you will find answer on questions 3 and 4. I will repeat them. So should I be concerned that running my vehicle with the light bar on constant blah blah blah, something prevent the battery from charging? How much current does the alternator supply in that or another situation? I'm checking that I'm going the right way soon. And many other similar questions like what if, how much. Just watch it. I will now show you the situation when we consume more than generator or alternator give us. So we consume about 7 amperes and the generator generates just about 3.5 amperes. Why? Because I use refrigerator this time. Let me show you if I switch it off. So consumption is about 3 amperes and generator provides about 3.5, a little bit more to charge the battery. So why I can't fix this situation much, because I need this slow speed. Today the weather is good. I need 3 kilometers per hour. I cannot set RPM too much in that situation. So, and that's why when I use refrigerator, I drain my battery quickly, and alternator is not enough to charge it. So what are options? It's up to you. It's up to your configuration. In my case, I have the second battery. I can switch this panel to the second battery and use it for the fridge until it's flat and charge it at home, or I can keep my second battery as the reserve battery. It's up to you. I just show you how I use that information. Now I will explain you when I use the second battery. So I use it right now. The first one was drained to about 12, and that's why I switched this panel to use the second battery. It means that fridge and stereo use the second battery, and you can see it's not charging from alternator. It's 12 now, and that one is charging from alternator. First of all, I will show you what we see there. So that is the situation when we cannot treat the health of the system. We still use 7 amperes because this shunt is done by the negative part, so it means that the whole consumption it shows from the first and second battery. The second is not switched here. That's my design, because I switch it locally there just for this panel, not for the system, not for the alternator. So it means the total consumption, and alternator is giving this value, but it gives this to the first battery, charge it, and it's free of the most heavy loads. And we cannot say that this is bad situation, because this is for the first battery and this is for both batteries consumption. So here you should have a kind of checklist and remember and understand how you designed your system to understand how healthy is it. Otherwise you would need, I think, 4 shunts by each battery plus side, and probably also one more. Yeah, well, doesn't matter. So you got the point. Yeah, it's up to you how you design. And then the next moment, I have seen people ask, like, if I use electrical motor, second battery, will I be able to charge them from switch and charge this battery from alternator? Guys, no, not with this Mercury 60, 40, 50. It gives, I don't remember right now, but I definitely remember that on 1000 RPM it gives 10 amperes or 12. I'm quite impressed that it gives that much. We will probably check it later, or maybe it was in this video. I don't know when I record this part. So, but at this moment, when we are in 800, it gives just the value you have seen for charging the battery. It cannot provide more, and if you don't have external charger and you are fishing several days, you will not be able to overcome this situation. Because look, what can I do now? The first is not yet charged. It will take quite a long time to charge from alternator. I could switch, in my case I designed this that I can switch any battery to anything, loss or alternator. I can switch the second battery so that alternator charging this battery. However, the first one will still not charged, and yeah, so you cannot do this at this RPM even for the whole day of fishing. You need external charger. In my case it's just 1 day fishing, so yeah, that might be okay. The first battery is health, I drain the second one, I will come to home and charge both of them, no problems. But if you are out of AC power, yeah, you cannot do this even with such small load like refrigerator. It uses about 5 amperes. The lights also use that 5 amperes, but lights you use for the short time, usually when you're driving, and usually at high speed in night time, or autumn, spring, at least here in Finland, in time when you don't need refrigerator. So it doesn't add extra to your consumption. So you need refrigerator in that nice weather, when you are doing slow trolling. So exactly in that weather you need refrigerator, and then it means that you are in lack of charging power. So I think you got the point. You can calculate everything. You can see the documentation for Alternator and understand how much power at which RPM it gives you. And I show you examples. I think I will continue to show them to you. By the way, I'm not sure if I already recorded this part where situation is clear about the health of the system. That is when we don't use the second battery at all. So how I do this in my case, this is not to lost power for the music when I switch to the first battery. So I first put here, I have a video about it. Then I connect the first battery for this panel without losing anything. Then I connect the music again. So now we don't use the second battery. You can see immediately it become from 1199 to 12 something, and voltage drop we see here. So now fridge and stereo, which is now on pause. Yeah, so consume from the first battery only, and alternator charging this. And now we can check the health of our system. You can see we consume the same 7 amperes, of course, because the shunt is by the negative side, and we provide only 4 amperes. We drain the battery. Yeah, so you got the point. You can do this just using 2 shunts. I have full playlist about, guys, this Santa Barbara, about all electric that I did this winter. You can watch there for details. You can ask me. I want to redo something, by the way. I think this winter, or probably even not winter, probably during summer, I actually want, because you see I sit here, I don't see anything there. I want to provide probably extra shunt to the dashboard and use Blue Sea Systems M2 probably here on the dashboard. Or maybe I not yet decide. I will keep this first one for the alternator by the positive side, but probably will remake this one to see system amperage, so it will show minus or plus all the summary. So I will need just remake something in this box. If you watched my, this is, by the way, positive side shunt for the alternator. Yeah, so the negative side there, I need to change something if I want to see summary. In that case, I can only see consumption of individual circuit when the outboard is switched off. So if I want to check, I can check it. I will see minus and how much power they uses. But I hope by that time I actually know consumption of each part of my system. Now I know that this is 5 amperes, these are 5 amperes lights, but it's easy to calculate knowing their power. I know how much this consumes, etc. So probably I will remake this so that I just look on the second one and I see minus or plus, and I understand is it good or bad. Too much information, right? here. Guys, another situation when you draw more power than provide. Really small RPM. Yeah, because I'm still hope 9:30, but I'm still hope to get some fish. Yeah, cannot go away because you see nice sunset. So, and that is when you have the minimum what is possible on this engine. Yeah, you cannot go lower. You can? You can't. Yeah. In that case, because there's still stereo on pause there, so we consume 3. Oh, now we can read really nice now without light, and we provide just a little bit, really small, yeah, on these RPMs. Now I will change them, and you will see how we will equalize this. I wanted to get first about 800 to show you that small difference will make huge difference there. Yeah, so with 800 we have 4 kilometers per hour. Yeah, and look at this, we still consume about 3 amperes, but we provide 4 for loads, because 3 for loads and about 1 extra because we are also charging battery. Resistance of the battery dropped because it's discharged, and I guess if we add more RPM we will see even more here, because I'm pretty sure battery needs more. Yeah, it is. If we would have a charged battery, then you would see equal numbers here. Well, a little bit more, yeah, and see, we have 5 here because the battery needs more. If I would increase even more, then we will get probably another few amperes for the battery. We won't see all 10, I think. Well, let's try. So that's the maximum I can set now, 5 kilometers, and we have you can see about 7. Yeah, I think it's not the limit for this RPM, it's just what is needed for the battery in that conditions. So guys, let's take a look at 1700. Yeah, so I'm still here, I can show you. So as you see, it provides 10 amperes and charging the battery, no problem with that. So, and you see 11 amps, so actually the battery can get more. It's all about RPMs. So as we added more, the generator, alternator can provide really more, because the battery needs more, discharge the battery.
so you can see the voltage drop. So,
and let me remind what batteries I use, remind or show if you didn't follow me, and then we will check quite interesting stuff about how much amperes hours they accepted during charging after that trip. So there's the first battery, Optima 975 here. Yeah, so let's check all numbers that we have. No, but number is not interesting. Yeah, that one. And there is Varta Blue, but I will show you the same battery I have there in my storage. So that Varta, there is initial one that I had in the board, the original one. Yeah, I have changed this to Optima, the big one, and the best battery actually, and that becomes secondary. And the original one, it has some issue, yeah, here, so I just use this as reserve battery in case of winch, for the winch. Winch? Do you call this winch? I think so. Here I have the up, and the first battery is charging from 10 amperes, as you can see, 10 number here, charger, and the second from the 7 amperes charger. The first is charged. Currently it is in the storage mode. Yeah, it was 0 amperes, now it's 0.1, but doesn't matter. So, and here we can see that it's charged for the standard half hour charging circle. Yeah, and here is initial voltage and voltage, and it accepted 4.7 amperes hour. We can see more statistic here in bulk, just 1 minute absorption, half hour, yeah, and then something in float. I don't know exactly what these numbers mean here in this app, but we just know that it took let's say half hour to charge it, or actually probably we can say 4.5, because float I think is also important before storage, because it's full charge. Yeah, so but for the second one actually it's not yet in the storage mode, is still in the float with 0.4 amperes. Yeah, so keep battery at constant voltage and fully charge it. And look at this, how much it took in absorption. Stage 6.5 hours, 20 minutes, and bulk charge, yeah, so it charged for it accepted 11 amperes hours. It's still not charged. So what I want to show you, I don't know all numbers exactly. If you know, let me know in comments. But we can see that from this 1 day of trip and using the refrigerator, actually I didn't use it all the time. Sometimes I took it off, turned it off. So refrigerator, stereo, media player, and just basic equipment, and we need to charge both batteries for that amount of time, about 7 hours and even more. So you can understand that alternator of the outboard cannot provide this. So that's the idea I wanted to show you. For the fridge consumption, we also can verify this label. For cooling is rated for 45 watts by 12 volts. So if we divide, we have about the same 4 amperes that we have seen there on the ammeter. Next part supposed to be a fishing trip number 3, where we should have been covered the next questions, but the following has happened. This time something really huge. Well, not really, but something good. Well, more or less. Just look at this, guys. Just look at this piece of crocodile. Wow. Never in May, never before. Climate has changed. Wow. Guys, look at this. It's the right fish. Why it's right? Because you can take this, because that is caught. It's the right size. And this is epic, because it's 31 of May, the last day when you can take that kind of fish. Terrific. Flasher, the local manufacturer. This head, local manufacturer. The rig is mine. Well, guys, I was really distracted with this fishing for about 4 or 5 hours, and so this part should be closed with this, because yeah, it's too much material. And guys, actually in the there was a third fishing trip. Current is 4th, I believe. Yeah, so where I tested mainly how much power we consume with different devices here, downrigger, trim tops, lamps, everything. So the focus was on that. Well, the main focus was actually probably on fishing again. Yeah, why do I stay here? Not for this content that nobody watch, for fishing. Yeah, so but there will be quite a lot of interesting material again, and actually this serious subject and questions to so-called experts or real experts will be also in that part. So for now, guys, thank you, subscribe, and yeah, see you next part. There will be answer on the question 5, how much power does something consume. On question 6, I already don't remember them, it was about 4 or 5 hours ago. Yeah, and I continue focus on fishing. Bye. Kisa, can I get my chair back? And tell guys what will happen if they will not subscribe.